on evaluation of crude drug. So we start with the part 1 that I have divided in two parts. Part 1. Part 1 will include crude drug and two of the parameters. So here is crude drug. Crude drugs are vegetable or animal drugs that contain natural substances that have undergone only the process of collection and drying. Natural substances can be of plant origin as well as animal origin. If we talk about plant origin, we have leaves, flowers, seeds, barks or other vegetable saps, extracts and secretion like gums and mucilage and raisins that we used as the source of drug. Coming and talking on the animal origin, whole animals, glands or organs, extracts and secretions have been used since early times as a source of herbal medicine. Standardization or evaluation. If we talk about the standardization or evaluation, it is made up of 3 points, that is identity, purity and quality. If we see identity, identity is the identification of the biological source of the drug. Quality, the quality of the active constituents present. And last, purity, the extent of foreign organic material present in a crude drug. So drug evaluation can be defined as the determination of identity, purity and quality of a drug. Standardization of herbal drug being the subject, it includes these 3 parameters in detail for the purpose of herbal preparation of herbal medicine. Now come importance of the evaluation of crude drug, that why we are doing so. Determination of biochemical variations in the drug, identification of deterioration due treatment and storage, reporting substitution and adulteration as a result of carelessness, ignorance and fraud. Because the main and the last aim of our study is for the preparation of a herbal drug. So if the drug is not pure, so it will also not produce the same potency and the efficacy of the drug will also be affected. Coming on the methods of drug evaluation, we have evaluation of the drug is done by studying its various properties like organoleptic evaluation, microscopic evaluation, physical, chemical, analytical and biological evaluation. So in part 1 of my presentation, I will be dealing with organoleptic and microscopic evaluation, and in part 2 I will be dealing with physical and chemical evaluation. Analytical evaluation and biological evaluation is also a part of standardization, but these are not mentioned in the syllabus, so it is covered under beyond syllabus portion. So coming to the first point, that is organoleptic evaluation, we can also say it morphological examination or microscopical examination. It includes shape, size, color, external marking, taste, odor, texture and fracture of the drug that is being under study. So we will be discussing it one by one. This refers to the drug evaluation by means of organs of sense, that is sensory organs, and includes other sensory organs like color, odor, taste, size, shape and texture. It includes the study of morphology and other sensory characters. If we talk about the character and the drug, for example, like brown color, if we say a brown color, the property is added with the cinnamon drug. Aromatic odor. Umbelliferous fruits have aromatic odor. Sweet taste. Licorice is marked by its sweet taste. Fractured surface. Cinchona has a fractured surface, you can say a rough surface. Wavy shape. Rauwolfia is famous for its wavy shape. And the size of the leaf. These are the 6 parameters on which we study about a particular drug. It includes the visual examination of the drug. For example, if we say it is a bark, it is an underground part of the drug. Leaves are used as flowers. So here are some examples. If we talk about bark, then kurchi is the example. Underground portion of the plant, that is turmeric and ginger. Leaves, digitalis. Flowers, saffron. Fruits, fennel. Seeds, nux vomica. Raisin, asafoetida. Wood, sandalwood. Gums, cassia. Entire drug, ergot, can be the example if we talk about the part of the drug that is being used. So coming to the next is shape and size. The next parameter, that is shape and size under morphological evaluation. If we say that the flowers are used as the source of the drug, so we should know the shape and size, then how to describe it. So the flowers, the floral parts include stigmas, corollas, anthers, ovary, receptacle. Leaves and leaflets, if we talk about that the digitalis, the leaves are used, so we have to explain the length, width, apex, margin, base, venation and the texture of the leaf and the hairs in upper and lower surface. The feel of the surface described as soft, hairy, smooth. So these are the morphological characters that we have to study while we are taking a drug under consideration. And when it comes to a leaf, then these are the few particular words that we should know and be clear that what is the apex, the margin, the base and the venation of a leaf if we are talking about. If we talk about the bark occurs in 3 shapes: flat or curved pieces, single quill, double quill. That is the curved portion of the bark that if we peel out the bark, that is the outer layer of the tree, of the trunk of the tree, then the outer layer, when we scrap it off, it curves. When it curves from both the ends, then it is double quill. When it curves from a single side, then it is a single quill. It is flat or curved pieces. Barks have 2 surfaces, an outer and the inner. As well we know, when we scrap off the bark from the trunk, it has an outer and the inner surface. The inner surface is usually lighter in color than the other outer surface. So next point is odor. Odor can be distinct, that can be differentiated. Indistinct, that cannot be differentiated. Balsamic, it smells like flowers. Aromatic and spicy. These are few odors which we talk about in case of plants. Or herbal drugs. Now is the taste. The taste can be acidic, that is sour, saccharine, that is sweet, saline, that is salty, alkaline, bitter, tasteless, that doesn't have any sense of taste, mucilaginous, pungent and acrid. These are some of the words that are used in the study, and one should be clear with these words. Coming to the next parameter of morphological evaluation is the color and the external markings that we see through our eyes. So it is one of the sensory character also. That white, for example, if we say, then starch can be the example. Pale yellow, then it can be ginger, squill, white pepper. Deep yellow, for example, peeled licorice. Light pale brown, example is nux vomica and fennel. Dark brown, for example, clove buds. Dark reddish brown, that is cinchona. Red, brick red color, for example, cinnamon bark, the inner portion. Pale green, for example, lobelia. And greenish brown, most of the leaf herbs are greenish brown in color. So these are few colors that we generally talk about, and depending on our visuality we can always state the color of the drug and the external markings if persist. Coming to the next topic of our standardization is microscopical examination. The one that has been covered was morphological examination, and the second one that is the part of this presentation is microscopical evaluation. And if we talk about microscopical evaluation, we have quantitative microscopy, histological microscopy, microscopical linear measurement. These are the three broad categories of microscopical examination under which we study. If we talk about quantitative microscopy, the parameters that it includes are stomatal number, stomatal index, vein islet number, vein termination number, palisade ratio, lycopodium spore method. If we talk about histological microscopy, it has stomata cells, trichome cells, phloem cells, xylem cells, tracheids, vessel cells. Microscopic linear measurement can include the size and the length, the width of the microscopic structures that we observe. It can be like stomata size, trichome length, phloem fiber length, starch grains and its type, to identify which type of starch grain does it have, calcium oxalate crystal, saying which type of calcium oxalate does it produce. So here we will be dealing each and every point in a bit detail. So coming up to quantitative microscopy, this method allows a more detailed examination of a drug. It can be used to identify organized drugs by their own histological characters. Before examination through a microscope, the material must be suitably prepared. This can be done by powdering, cutting thin sections of the drug, or preparing a macerate. That is the parameters that we are going to follow. The drug is prepared accordingly. For example, if we have to do the TS, then the transverse section of the drug is cut and then it is observed through microscope. The parameter is palisade ratio. It represents the average number of cells beneath one epidermal cell. If we talk about the TS of the drug, then the first layer that we study is the epidermal layer, or the outermost covering of the leaf cells. So the number of palisade cells, or you can say the pillar-like cells beneath one epidermal cell, is said to be the palisade ratio. It is determined from the powder drug with the help of camera lucida. For example, Atropa belladonna has 5 to 70 ratio, Azathoda basaca has 5.5 to 6.5. Cassia angustifolia can be having 5.5 to 10 on the upper and 4 to 7.4 on the lower surface of the leaf. That's Senna variety. We are talking about the Senna variety. Digitalis lanata, it has 2.5 to 6.5 ratio. The ratio we are talking about in the range, and it is different for different drugs that we are using and studying. Now coming to the next parameter is the stomatal number. Stomatal number, it is the average number of stomata present per square millimeter of the epidermis is known as stomatal number. So just as I said before, that epidermis is the outermost covering of the leaf, and when we tear the epidermal layer, we have the number of stomata present on it. It can be the upper will have less number and lower will have more number. For example, in case of Atropa belladonna, the upper epidermis has 7 to 10 and the lower consists 77 to 115 number of stomata present. Same in Dhatura metal, we talk about upper epidermis will have 147 to 160 and lower will possess 200 to 209. Ossimum sanctum, that is Tulsi, and if we talk about it, upper epidermis possesses 64 to 72 stomatal number and lower epidermis possesses 175 to 250. The stomatal number is like the fingerprints of a particular human. As they are identical, similarly the stomata and its number are identical for a particular species in the plants. That is why we are using it as a standardization parameter and to identify the plant. Stomatal index. Stomatal index is the next parameter that we have talked about. It is the percentage proportion of the number of stomata to the total number of epidermal cells. Stomatal number varies considerably with the age of the leaf, but stomatal index is relatively constant for a species. So here you have to pay a bit attention that stomatal number varies considerably with age factor of the plant, but stomatal index is constant for a given species. So if we are not taking age as a factor, then we can go for stomatal index as the parameter for standardization. It can be calculated by using the formula SI, that is stomatal index, is equal to S upon S plus E, where SI is stomatal index, S is number of stomata per unit area, E the number of epidermal cells in the same unit area. For example, if we talk about Atropa belladonna, upper epidermis is having nil and the lower possesses 20.2 to 23.0 as the stomatal index. Vein islet is the second parameter that we have to learn for microscopical evaluation. If we talk about vein islet and vein termination, these are the two parameters of leaves. Vein termination is the end point of the veins, and vein islet is, we can somewhat say, like the island, or we can say a piece of any area that is closed within four boundaries of the veins is one islet. So vein islet number is defined as the number of vein islets per square mm of area leaf surface. That is, it contains 9 to 12, that is, if we talk about Andrographis paniculata, then it contains 9 to 12 vein islets in an area of square mm, Bacopulmonari 6 to 13, Cannabis sativa 18 to 24, Digitalis purpurea 2.5 to 3, and last Eucalyptus globulus. It contains 8 to 13.5 vein islets, that is a closed boundary, all the four sides, or you can say area of the vein that is closed by four sides with the veins. The next is vein termination, and if we talk about the vein termination, we can see that it contains, it is a number, it is defined as a number of vein termination in the surface between the midrib and the margins. So it is per square mm area that has been, the veins that has been terminated in that area is that vein termination number. So now if we talk about Lycopodium spore method, that is another parameter which comes under microscopical evaluation method. The Lycopodium spore method, it is widely used, especially chemical and other methods of evaluation of drugs fails to determine quality, where purity and quality, as we all are studying the purity quality of the herbal drug, so where the other evaluation parameter fails to determine the quality, we use Lycopodium spore method. In this method, Lycopodium spores are very characterized in shapes and appearance and uniform in size of 25 mm. On an average, 94,000 spores present per mg of Lycopodium powder. It consists of well-defined particles which may be counted. The Lycopodium spore, actually the spores that is obtained from this Lycopodium species have a definite shape. So when we count on a microscopic slide, it can be easily counted because it is well-defined particles and that may be easily counted. Single-layered cells or tissues, the area of which may be traced under suitable magnification and actual area is calculated. The objects of uniform thickness, the length of which can be measured, and actual area can be calculated. So the percentage purity of an authentic ginger powder calculated as follows. For example, the formula that we use for calculating the percentage purity of the drug is N into W into 94,000 into 100 upon S into M into P, where M stands for the number of characteristic structures, that is starch grains in 26 fields. That is the starch grains that we are using, of what? Of ginger powder. We are using a ginger powder as the standard drug, and the starch grains of that ginger powder is mixed with the Lycopodium spores. So N is the number of starch grains, W is the weight in mg of Lycopodium spores taken, S the number of Lycopodium spores in the same 25 fields that we are studying, M is the weight in mg of sample calculated on the base of dried sample at 105 degrees centigrade, and P is 2,86,000 in case of ginger starch grain powder. So this is the method that we use to calculate the percentage purity of the crude drug. Now we come to the microscopical evaluation. Microscopical examination includes stomata, trichomes, calcium oxalate crystals. So we will be dealing one by one. Stomata, that was stomata and its type. Stomata are primary and important functions. The primary and important function of stomata is gaseous exchange. We all know it is a minute epidermal opening present on the aerial parts of the plant. Stomata consists of central pore with two kidney-shaped similar cells called guard cells and varying number of subsidiary cells, or we can say epidermal cells. That is S and E we have used in the formula of stomatal number and stomatal index that we have calculated. So epidermis of the leaf shows different characteristics, for example cuticle, stomata and trichomes. Here is the picture that depicts the stomata open, which have the two kidney-shaped bean cells, and in between that the white opening is representing the open state of the stomata in which the gaseous exchange is taking place. And on the other hand, we have the next figure of a closed stomata. The two kidney-shaped cells are stick together and the pore has been closed and no gaseous exchange is taking place. So in next slide, in the coming slide, we are talking about the types of stomata that are generally present and generally found in the surface or over the surface area of the plants. We have parasitic, and the other name is rubaceous or parallel cell stomata. As we have stated, that is parallel cell, the kidney-shaped cells we have that we call that guard cells, and the epidermal cells. The two cells are parallel in position, then we call it as parasitic or rubaceous or parallel cell stomata. In the stomata, two guard cells covered by two subsidiary, only two subsidiary cells will be present, and that too, the condition of the epidermal to the guard cell will be parallel. For example, senna. Senna leaf contain parasitic stomata cells. Coming to the next is diacetic, or we can also say caryophyllaceous or crossed cell stomata. In this stomata, the guard cells are covered by two subsidiary cells on right angle to that of stomata. That we were talking about the guard cells, and when the epidermal cell is parallel to the guard cell, it is parasitic, but if it is at 90 degree to the guard cell, then it is diacetic. In both the conditions, the number of subsidiary cells is 2. For example, the diacetic stomata is present in peppermint. Coming to the third one is anisocytic or cruciferous or unequal cell stomata. In this stomata, number of guard cell is 2, but covered by 3 subsidiary cells, and in that one is small in size with the other two epidermal cells. That means when we are talking about 2 guard cells, it is covered by 3 subsidiary cells or epidermal cells, and in the case of 3 subsidiary cells, 2 cells are of the same size and the third one is a bit smaller than the 2 subsidiary cells. This kind of stomata is present or found in Datura plant. The fourth one is anomocytic or ranunculus or irregular cells. In this type, stoma is surrounded by varying number of subsidiary cells, that is more than 3. We have talked about 2, and on the basis of the position of the subsidiary cells to the guard cells, we have classified as parasitic and diacetic. Next, if we count one more, then we have 3 subsidiary cells, and position is 2 are of the same size and one is smaller, a bit smaller than the 2. And now coming to the fourth one, anomocytic, which have varying number of subsidiary, we can say it more than 3 subsidiary cells, then it is called anomocytic or ranunculus or irregular cell type of stomata. In this type, stoma is surrounded by varying number of subsidiary cells, for example digitalis. Actinocytic or radiate celled stomata. 2 guard cells are surrounded by radiating subsidiary cells. Like we have seen the flower of rose, the leaves, the petals are radiating. That is central part से अगर हम radiate करेंगे उसको, तो वो एक circle shape में उसके subsidiary cells arrange होते हैं. Here is the pictorial depiction that we were talking about. Anomocytic, that we have more than 3 subsidiary cells. Anisocytic, 3 subsidiary cells having 2 of same size and one is smaller, a bit smaller. Diacetic have 2, but it is at 90 degree to the presence of guard cells. And the fourth one is parasitic. The subsidiary cells is parallel to the guard cells. Parasitic cells, it is now a bit clear. Actinocytic, that was we have talked about the radiating cells. That the subsidiary cells are arranged in whorls. That is 1 layer, then 2 layers, then 3 layers. That is around in circular arrangement. The 2 more type we can talk about is tetracytic, that has 4 subsidiary cells, and gramineous, that has 2. But the guard cells, the length of the guard cell is more than that of the subsidiary cells. So these were the types of stomata found in the plant. Now we come to talk about trichomes and its type, and its presence is one of the evaluation, or we can say that standardization parameter for the drug evaluation. Trichomes and its type. Trichomes are tubular, elongated or glandular outgrowths of the epidermal cells. Trichomes are also called as plant hairs. The same way that we have hairs over our skin, the same way the plants have these hairs, and these are termed as trichomes. Trichomes consist of 2 parts, that is root and the body. The root is embedded on the skin of the plant, that is epidermal layer, and the body, that is trichome, present in most of the plant parts and are functionless but sometimes perform secretory functions. Depending upon the structure and the number of cells present in the trichomes, they are classified as covering trichomes, glandular trichomes, high gathodes, or special types of trichomes. If we talk about the classification of trichomes, then we can have multicellular as well as unicellular trichomes. The trichome which is made up of a single cell is termed as unicellular, and which is made up of multiple cell, it is known as multicellular trichomes. The trichomes can be further divided as glandular and non-glandular. So glandular will be hydrophilic and lipophilic, and non-glandular can be vascular hair, spiraliform hairs, stellate, T-shaped, and these are the plants which have these trichomes, and we can say that we can consider as the examples, or we can say the plants and their special type of trichomes that are present in it. The flattened can be further classified as, say, scales, peltate, and dendroid. Next is calcium oxalate crystals and its type. Calcium oxalate crystal. We all know calcium oxalate crystals are found in plant, and how does it develop in plant? When oxalic acid, that is formed in the metabolism, is present in the plant and it is poisonous. So to change the nature of the poisonous substance, it combines with calcium and forms calcium oxalate crystal. Oxalic acid, when combines with calcium ions, forms calcium oxalate crystals in the plant. So several cell components present in vegetable drugs, the inorganic crystalline compound by virtue of the specific shapes can be utilized for the identification of herbal drugs. Due to this reason, they are called as diagnostic characters of the plant. We are talking about the evaluation. So these particular features which are specific to a particular plant can be considered as one of the diagnostic characters for its evaluation. If we say that the calcium oxalate crystal is of cubical shape, that is present in senna and glycyrrhiza, makes it identifiable and distinguishable. Rhombic, diamond shape. Tetragonal, that we are finding in onions. Monoclinic, all 3 axes are unequal, for example gall. Acicular, long cylinder pointed bundles, for example squill and cinnamon. Rosette or or we can say cluster. If the calcium oxalate is found in cluster, aggregation of cluster, for example clove and arjuna, microspheroidal, minute structures, for example henbane. These are the shapes of the calcium oxalate generally found in some plants. Here is the pictorial depiction that is found in the cells. This is rosette. We can have cuboidal, rhombic and other different types of shapes of calcium oxalate that are present in the plants. Now the other diagnostic feature is starch grains and its type. What is starch? It is the storage polysaccharide of most plants. Human beings obtain it from cereal grains, for example rice, wheat, legumes like peas and grams and beans, potatoes and tapioca and banana, etc. It is a polyglucan homosaccharide and is formed as the end product of the photosynthesis. So the end product of photosynthesis is starch, which is stored in the plant, and their shapes can be used for its identification or can be used as one of the diagnostic parameters. Starch is stored either inside chloroplast or special leucoplast called amyloplast. Starch occurs in the form of microscopic granules called starch grains. Starch grains may occur singly or in group. The two types are known as simple and compound starch grains. Starch grains may be rounded, oval, polygonal or rod-shaped in outline. Each grain have a number of cells or layers arranged in concentric or eccentric fashion around a proteinaceous point called helium. So, if we are talking about the cell of a starch, then we have a helium which has a fluorescent light, or we can say the starting point of a seed, and all around we have a concentric or eccentric cell layers arranged. That is the shape of the starch grain, and it can be of rounded shape, oval shape, polygonal shape or rod shape, and depending on the shape we can identify the plant. Here is the pictorial depiction. If we say helium, that I was talking about, it is having a concentric multiple layers of starch, that is A. B, it is a group of compound starch grains of potato. A was simple starch grains of potato. If we talk about C, it is a simple starch grain of maize. D, a simple starch grain of pea. E, a compound starch grain of rice. F, a compound starch grain of oat. G, a simple starch grain of wheat. H, a simple starch grain of banana. So these are the different shapes of starch grains that can be used as one of the diagnostic parameter for a particular plant. So that was all about in this part 1. I will be soon coming up with part 2, the remaining part of the unit 1, covering the syllabus of evaluation parameters, chemical evaluation and physical evaluation. Thank you till now.